Hey guys, it's Beast. I want to start this video by saying that I'm not an engineer or any of the sort. I will not pose as one. I'm just a computer enthusiast, and I just like computers in general, more so the gaming side of it. So with that out of the way, I will start talking about the 9070 XT, which is the main focus of this video. Um, I've owned a 9070 XT Red Devil since December of 2025. Previous to that, I was running a 6750 XT since like about 2024 when I built this system. So I decided to upgrade because I was also very intrigued and curious about the 9070 XT. And there was no enough data about some of the things about it that I could find anywhere. So I got it partly because of that. And I'll be talking about like some of the experience that I've been having with this GPU since December. So as many know already, this GPU consumes 304 watts TDP as it's configured by the specs AMD provided on their website, and that is also here provided on Tech PowerUp. 304 watts TDP, or the total power that it consumes, which we know it's not necessarily entirely true, more so for cars like the Red Devil. It's at 330 watts tops, and it, of course, peaks over that. So yeah, anything that is closer to a reference model, since AMD did not release one, is the Power Cooler Reaper, I believe. It's like one of the closest cards that you can get to something like reference spec. But yes, right now, many people have noticed and know by anything like owning or seeing videos of benchmarks and tech reviewers that the 9070 XT uses quite the power, because it literally runs at the power target all the time when it's under load on heavy titles and stuff, like around 99 to 100% GPU utilization. It will be running at the power target basically and spiking. And if you run anything like ray tracing, it will spike a little more. So yeah, I wanted to say that I've been doing my testing with lowering the core clock. I have a screenshot of that. I have minus 500 megahertz, since there's only a frequency offset slider, and it's capped at minus 500 and plus 1000 megahertz. Why plus 1000 megahertz? I don't know, but AMD did that, and it doesn't really have any sort of sense to me. The card at zero frequency offset is set to 3400 megahertz. If you open metrics, sensors, apps like Hardware Info 64 in the sensors only mode, you will notice that it says the max clock or the frequency limit is set to 3400 megahertz. I think it's kind of silly, because I don't think this should be set like how CPUs are configured. More so like, using the boosting algorithm of Ryzen as an example. Because the PBO frequency offset or boost override is applied more so to something like the two best cores of a given CCD, unless you have a certain threshold that all the cores can actually meet that frequency, right? Yeah, I don't think they should have configured this that way. They could have done a manual frequency setting, just like RDNA 2 and 3. You see that I have it on the 6750 XT, 2452 minimum, and 2552 max. The 6750 XT came out of the box with 2669. It's an XFX Quicksilver model, and it would do up to 2700, 2750 megahertz boost for some reason. It was not really that good or completely reliable because it was running the temps up. So it was not sustainable. It needed more power to actually sustain 2700 megahertz reliably in effective clocks. So it's a pattern that I've been seeing with some of the Radeon GPUs. For example, the 7900 XTX running at 2990 megahertz max clock, or not running but having it set as the max clock in Adrenalin for some reason. I've noticed that it has caused issues for some people. Some of the people that I have helped troubleshoot issues, I just tell them to set the max clock to 2700 or 2750 megahertz. That usually solves the thermal issues. Because no matter how you repaste the 7900 XTX or put the PTM 7950 and thermal putty on the VRMs and memory chips or pads, it will not solve the issue, which would be running like if it was out of the box as a water-cooled card. Which I don't really understand why AMD has that issue going on still. I thought they would fix it over time with driver updates. Has not been the case. But yeah, it's something that I've noticed, and I've also noticed that some of the GPU vendors push the GPUs a little bit too much as well. So it's like, it's an issue of both. And I would like for AMD to just do a change so it doesn't really cause issues for people. Because I have seen it with some of the people that I know that own 7900 XTX or some of the RDNA 3 cards having issues with driver timeouts and also thermals not being great. I don't see it being talked about properly, or not just properly, like some of the people not being necessarily aware why the issue is happening in the first place. Sometimes it can be that I mentioned, those issues, or something like Windows driver updates, you know, if you have the automatic driver updates on, which I turn off because Windows always causes a clusterfuck drivers. But yes, the 9070 XT is a pretty good GPU. Unfortunately, the circumstances are that it's pushed past the efficiency curve and out of reliability, because it is a pretty good GPU. It runs, 3 gigahertz plus. They have achieved that. I'll give them that. But you don't see GeForce cards being pushed to 3 gigahertz out of the box. I know that there's issues with some of the board partners or GPU vendors for GeForce cards. There's always some. And that there's some issues with NVIDIA altogether. I know. But that's not like the point of the video. The thing is that you don't see those GeForce cards being pushed out of the box at 3 gigahertz plus, even though Blackwell has a pretty good architecture that can do it at 3 gigahertz. Just that they choose to have at least the reliability of the core clocks and being able to have the power managed, you know, because of dynamics like gaming and stuff and GPU loads. I've noticed that the 5070 Ti, in some of the data that I can check on review channels as well as benchmark channels, in gaming at 1440p, the 5070 Ti can go anywhere around 235 watts in some of the average, up to 270, 280 watts with no issues. The 9070 XT does not, because unlike the 5070 Ti being around on average about 2850 megahertz capped. The 9070 XT is only having a ceiling, because that's what the frequency offset is, having a ceiling of 3400 megahertz. Again, doesn't make any sense why the ceiling is that high, because it's not like the CPU. It's not going to have like two or something like that, like two cores that will boost to that in a certain workload, and then the whole cluster or group of cores boosting to a certain threshold, so it keeps at a reasonable power and thermal target. GPUs are parallel, and I don't think it's a good thing that the 9070 XT is just pushed that high. I think maybe up to like 2900 megahertz tops would have been good. But not even that, I would like to have manual control of the frequency, or at least having a lower frequency offset of down to 1000 megahertz below. So I could adjust it manually to have a lower ceiling and better thermals and overclock management, as well as the power management, without having to do what most of the people that I've seen do, which is reduce drastically or heavily the power limit, and just not having a headroom for the GPU to use power when it really needs it. I also have noticed that with some of my testing, the GPU has been able to use power about 245 to 270 watts up to the power target of 290 watts, which I have, with the negative 12% power limit. I've noticed that it doesn't really have any big performance hit or anything like that. Rather, it runs pretty good and cool. Go to the metrics that I gathered from playing for a few hours Warframe with different like tile sets and missions, in which some of the worlds or the tile sets have different loads. Some of them will allow the GPU to perform at 100% with the frame rate high, which can cause the GPU to run at like 275 to up to the power target, or dynamically use power to 245 up to the power target, depending of what it's required by the GPU. Just with these settings, you can see that thermals are pretty good. I think my room temperature was about 25 to 28 degrees Celsius at the time. It was not really great. It was also not that bad, and it wasn't worse because of GPU, dumping really hot air. I think this is reasonable. The core voltage at 0.936 volts, I think it's pretty good. It's the lowest it can do with negative 45 millivolts. I think that is the most sensible voltage offset that you can do on this chip without losing stability, causing any instability whatsoever. And the way that I can actually test that is because Warframe is very, very good to test most of the time instability on GPUs. If I do anything like 50 or lower, minus 50 millivolts, at times it will cause Warframe to crash and for the GPU driver to time out, which tells you that it's not stable. You can always, if you use Adrenalin, you can always put individual game or program settings and save them. But I'm more of the person that likes to have a global setting that can work on everything and still have really good results across the board. I think that's how it should be out of the box with these cards. And yes, I just found out that it's just not really reliable to have a really high power consumption up to staying at the power target all the time because the GPU's running a little bit too much of a core ceiling, being too high. And the thing is that also the 5070 Ti, even though the things are not comparable with architectures, of course, is that the 9070 XT has 64 compute units. The 5070 Ti has 70 stream multiprocessors or cores. It's not directly comparable, but there's also this thing that it says 64 RT cores on the 9070 XT and 70 on the 5070 Ti. There's one thing that is not mentioned often, is that GeForce RTX cards have dedicated ray tracing cores. Radeon GPUs and the current generation that has ray tracing, they have the ray tracing computing done on the compute unit itself. There's no separate ray tracing units, as far as I know. They just reworked and got to improving the BVH computations and stuff on this generation. This architecture actually does pretty well with ray tracing, and it can do path tracing. Path tracing is still not there when it comes to real time in gaming. It still needs a lot of work. Not even a 5090 can do it reliably without using a lot of things and, you know, heavy upscaling as well as frame generation. So yeah, it's still not there even on this gen of cards, but it's a good thing to note that I don't think many people think about, or that is mentioned by some of the review outlets or tech channels. Not often mentioned that AMD still does not have dedicated RT cores. The other thing is that AMD has a 357 square millimeter die size, and NVIDIA has a 378 square millimeter die size for the 5080, and by design, because of cut down die or core configuration, the 5070 Ti, of course. What I'm getting at with this is the power density. The 9070 XT has a 304 watts power limit, as it is by the spec sheet from AMD, right? Divided by the 357 square millimeters, you have a power density of 0.85 watts per square millimeter. On the 5070 Ti, you have the 300 watts divided by 378 square millimeters, which equals to a power density of 0.79 watts per square millimeter. So that also tells you that the 5070 Ti can operate with better thermal efficiency. But I mean, it varies depending, of course, on coolers as well as the board designs and such. Those things also affect how GPUs perform and how well cooled they can be. But yeah, the thing is that, of course, you're not going to be having the GPU running at 300 watts all the time. More so when you're like, much less when you're gaming and at 1440p running the stock clock. Maybe even if you like lower the voltage to a certain level for the frequency, it will probably even do a better job with performance and also lowering the thermals. the 5070 Ti actually has a little bit more headroom for that than the 9070 XT, and it's by design because of how the 9070 XT is configured, like I mentioned. Plus the larger die, of course, being able to kind of dissipate heat better in a way. Like I said, you know, architectures cannot be compared one-to-one because they're pretty different, but you can at least have a general idea and be able to reference things and be able to understand why an architecture works the way it does and the other does the way it does, of course. But I believe that AMD could have at least released the 9070 XT with a little bit more of a strict spec and what could have been done out of the box. Because I think up to the 2950 megahertz, out of the box would have been fine for stuff like, you know, the premium models. So you would have at least still the power management done properly, not having the GPU be pegged at the power target all the time on 99 to 100% utilization in games or programs. Because I think some of the issues that people might actually be experiencing with this architecture, more so with the 9070 XT, is because of the high ceiling for the core clock. I disagree with that choice. I don't think, and again, I'm not an engineer or any sort of expert. I'm just an enthusiast. I think they could have done a better job by having the GPUs with a certain threshold and strict spec sheet, so they could be manageable and still give the choice for the enthusiast and anybody that wants to do any changes to be able to do it manually or just change by presets that are dedicated to it. I don't think it's a good idea that one of the things people resort to for the 9070 XT is reducing the power limit. I reduced by minus 12% because I think 290 watts is fine for this card. For the performance target, it's not bad to have that power ceiling. I just believe that the core clock is the issue. That is what causes it to run high. It's not that the GPU architecture is inefficient. It's more so how it's configured. So yeah, and it's a pattern that I've seen on Radeon across at least these 3 generations now. And I would like for them to just not push too much out of the silicon, because I've seen some really bad dead cores and stuff from Radeon, and I know that there's some repair guys that don't like working with Radeon cards and fixing and stuff because of that. And it's just because of how it's not even the architectures, it's just how they are configured in the firmware, which again, I just don't agree 100% with AMD on doing that. But yeah, if anything, I will be working towards having data for gaming benchmarks done. I hope this week I can actually release a video, if not the next one, if nothing major happens that, you know, keeps me from being able to do it. I will be acquiring some of the games that I can that are mostly popular amongst tech review channels and gaming benchmark channels, so I can showcase the difference between stock and the tuning that I have. I will also be providing the settings of my tuning in the comment section for anybody that wants to try my method, or at least, you know, the tuning that I have right now currently running. I'm running MSI Afterburner because RTSS introduces less overhead than the the metrics overlay for Radeon does. Sometimes it introduces some overhead and stutters. And I have not experienced such thing, at least with RTSS, or no major overhead at least. Plus MSI Afterburner is lightweight. It doesn't have like anything bloaty that causes any overhead either. So I'd rather run that. The other issue that I have with Radeon Adrenalin is that the CPU metrics software has issues with causing readout errors on something like hardware info 64 metrics. Sometimes it will cause the core clock to be misread and, I don't know, go to the like 20,000 megahertz on a core, which is not true because it would be a dead CPU at that point. And have other readout errors like CPU temperature with 0 degrees Celsius out of nowhere. So yeah, and I've also noticed that it likes to cause readouts to go haywire for fabric clock, memory controller clock, and stuff like that. Like, you know, it just raises the clock for those things, which is not true because that doesn't happen. They're fixed basically for the CPU. But yeah, not to keep going on a tangent about that. Back to the point. I just really wanted to talk about this thing with the RDNA 4 architecture because I don't see it being spoken about this way and with these details. I also don't see anybody doing these sort of tuning settings like I have done, or I've probably just seen like one or two on forums, very few of them. And like I said, I don't think it's good to rely on lowering the power limit so the card runs cooler and stuff. I think that is not the way to go about this. It shouldn't be shouldn't be the resort. I think maybe running the card with the power limit, for example, since I have a Red Devil model, instead of the 330 watt, being able to put it down to 304 watts or closer to that, or 300 watts, or have it like I have it right now, which is 290 watts limit. I think that's good. But yes, I just wanted to talk about this and be able to shed some light and maybe be able to guide people into understanding this architecture a little bit more in how it behaves, how this card behaves, and why it behaves the way it does. And it's because it's not really supposed to be running 3 gigahertz plus. I think that is something that should be left for anybody that wants to choose overclocking it manually or just changing the preset to that. I think AMD would have done a better job if they had done it that way. Because I just think it's just introducing some issues. And I know they're also doing this because they have to compensate for the bandwidth, because the memory that they're using is GDDR6 instead of GDDR7, which is on Blackwell. So they have to compensate in a way, and I understand that, but it's also not a good way of doing it by compromising any reliability and also the power consumption, as well as the thermals, because you have Hynix die memory chips, which run hotter than the Samsung memory chips. And the other thing that I want to mention on top of that, looking at the Sapphire Pulse, like all of the layouts for these cards, you see that the core is here closer to the PCIe, and it's so it also has the data can be transferred quicker. Of course, I can't tell you every single detail about this because I'm not an engineer and I haven't really gotten to that part yet. But I can tell you at least on the fact that the cooler, it's a plate shared by the memory chips and the GPU core. So the GPU core is going to saturate that plate and cooler. The memory chips will not have any headroom left to actually cool themselves properly with it. So the Hynix chips, which already are running hot, will not be able to cool off quickly enough to keep a reliable and sensible temperature. And the argument that those memory chips are good for 105 degrees hotspot or max temp is not good. It's not valid because you should not run in a critical temperature your computer components if you want to keep them running for a pretty good time span, have a good longevity out of them. So yeah, it's basically that also the reason, being the core clocks being very high, causing the GPU to run hotter. And also, if the cooler for a certain model is not great, plus the thermal interface or thermal solution is not good, it will cause more issues down the line. And that's where you have to work towards troubleshooting, RMAs, and all that, and not having any satisfaction out of your hardware. And it's because of those oversights and issues. I think it shouldn't be, in this day and age of technology, it shouldn't be an issue whatsoever or anything. It shouldn't even be an afterthought. But again, it's just my opinion and my point of view on things. And yeah, I will be working on getting those benchmarks done as soon as possible, being able to showcase things. I also want to mention the fact that I haven't really seen data out there about 5070 Ti running Warframe with the metrics on RTSS, having every single metric for the core voltage, the uncapped frame rate. I just really haven't found anything about the 5070 Ti for that game, and want to be able to reference how it performs. But yeah, if anybody has the, if anybody wants to contribute to my research on that and the data that I can get, if you could provide that, I would appreciate it. Anybody that, of course, has an account of Warframe and can run the game for a pretty good amount of time, the GPU stock at least, doesn't have to be tuned whatsoever. I just want to be able to have the reference to be able to, have data to compare to and also review, because I just, like I said, don't find anything. I would appreciate that. Other thing being that I just would like to own more hardware, but I'm not financially able to at the moment. Otherwise, I would try it myself. But yeah, if anybody is willing to do that, I would really appreciate it. Could leave a comment or something letting me know that you would like to contribute to that. But yeah, another thing, I think I'm probably going to be doing more content about this sort of thing, because I really like it. My channel is centered on gaming. I just haven't really done content as much as I'd like to, but I've been getting back on that. So yeah, I hope this has been pretty pretty insightful. It has been interesting and has provided some sort of education and valuable info. I hope that I can keep providing such content and be able to at least educate myself over time, as well as being able to impart the knowledge that I get from these things to others. So yeah, if there's any sort of corrections that have to be made and such, or any sort of feedback, leave it in the comments. I would really appreciate that. But yeah, I think this is pretty much all I have to say about this. I'm not sure that I have anything else to share. other than the benchmarks and info that I will have prepared for that next video. So yeah, I really appreciate the view and stuff, and making it this far in the video. So yeah, that's pretty much it.